Every computer you've ever used has a secret backbone that most people never think about, yet it's literally holding everything together. That circuit board connecting your processor, memory, and graphics card, it started as IBM engineer Patty McHugh's solution to a messy wiring problem in 1981. Today, we're tracing the incredible evolution of motherboard design from the 1950s to predictions for 2100. You'll understand how these boards went from simple connectors to AI-powered orchestrators, why form factors exploded in the late 90s, and what quantum integration might look like decades from now. Let me bring in someone who's been following this evolution closely.
You know, when people think about computer evolution, they focus on processors getting faster or storage getting bigger. But the motherboard? That's the unsung hero that made all of it possible. According to the page content, a motherboard serves two primary functions. It supports components like the CPU and RAM, and it facilitates communication between them through etched circuits.
Right, but before we had motherboards, how were computers even connected?
Great question. In the early days of computers, we're talking 1970s, computers were these massive mainframes or mini-computers. The concept of a motherboard didn't exist in the modern sense. Instead, systems used backplanes or custom wiring to connect components.
So, like, everything was just wired together manually?
Exactly. Each computer component required one or more separate circuit boards. The page content mentions that in the late 1960s, a CPU consisted of numerous integrated circuit chips attached to multiple PCBs. It was this sprawling mess of connections.
That sounds like a nightmare to maintain.
Oh, it was. But then 1971 happened. Intel created the 4004, the first microprocessor. This laid the groundwork for modular computing, though early systems were still built on custom boards with no standardized layout.
And when did we get our first taste of what we'd recognize as a motherboard?
1975 with the Altair 8800. Often considered the first personal computer, it used an S100 bus, basically a backplane system with slots for expansion cards. The page content describes this as an early precursor to the motherboard, though it lacked integrated components like modern boards.
So we're getting closer, but still not quite there.
Right. The real breakthrough came in 1981 when IBM introduced what the page content calls the first true PC motherboard with the IBM PC model 5150. This was designed around the Intel 8088 processor running at 4.77 MHz.
Wait, 4.77 megahertz? My phone probably runs at like 3 gigahertz. That's a massive difference.
Ha, yeah. But here's what made it revolutionary. This motherboard featured a 16-bit ISA bus for expansion cards, a BIOS chip, and sockets for the CPU and RAM. Initially, it supported up to 256 kilobyte of RAM.
256 kilobyte? That's like one photo on my phone.
Exactly. But the key innovation wasn't the specs, it was the integration. According to the page content, this was created by IBM engineer Patty McHugh and was originally called the planar breadboard. It had chips wired together and housed the RAM and CPU along with other components.
The fact that it started as someone just trying to solve a wiring problem is kind of amazing. Like, Patty McHugh probably had no idea she was creating the foundation for every computer that would follow.
That's the thing about foundational innovations, they often start small. But IBM's design became a de facto standard due to their market dominance, even though it was proprietary.
And then what happened? Did IBM just keep iterating?
They did. 1983 brought the IBM PC XT with support for a hard disk controller and more expansion slots, 8 ISA slots total. This introduced a more modular design that allowed third-party manufacturers to create compatible components.
So that's when the ecosystem really started opening up?
Exactly. And 1984 was huge. The IBM PC AT featured the Intel 80286 processor and introduced the 16-bit AT bus, later standardized as ISA. The page content notes this included integrated floppy and hard disk controllers, reducing reliance on expansion cards.
Interesting. So we're seeing this trend toward integration even back then.
Right, and the AT motherboard form factor was 12 by 13.8 inches. That became a standard for years, defining the layout for power connectors, expansion slots, and I/O ports. By the mid-1980s, companies like Compaq and Dell were reverse engineering IBM's designs.
And that's when things really exploded, right? Like, suddenly everyone was making motherboards?
The page content shows this incredible timeline of innovation. 1984 brought the full AT form factor, 1985 the baby AT, 1987, Western Digital developed the LPX form factor. But the real game changer was 1995.
What happened in 1995?
Intel released the first version of the ATX specification in July 1995. According to the page content, this established a standardized layout and improved power management, making computers more efficient and upgradable.
And ATX is still around today, right?
Absolutely. But here's where it gets wild. Look at this explosion of form factors. 1997 alone brought us the NLX form factor from Intel, DEEC, and IBM, the first AGP support, and the Micro ATX specification in December.
That's like 3 major innovations in 1 year. Were they just throwing everything at the wall to see what would stick?
It really feels that way. 1998 brought WTX, 1999 Flex ATX, 2000 ETX from Contron, 2001 had both UTX from TQ Components and Mini ITX from VIA Technologies. The page content shows this incredible pace of innovation.
And somehow most of these form factors are still relevant today. Like, you can still buy Mini ITX boards.
Exactly. And 2003 was another pivotal year. That's when PCI SIG introduced the PCI Express standard, and we got the Nano ITX form factor. PCI Express was huge because it offered improved data transfer speeds compared to older interfaces.
PCI is still the standard today, right?
Yes, but it's evolved dramatically. The page content mentions we've gone from PCI 3 to 4, and now PCI 5. These advancements dramatically improve bandwidth and reduce latency for high-performance applications like gaming and AI.
Speaking of AI, that seems to be a huge trend now. What's happening with motherboards and artificial intelligence?
This is where it gets really exciting. According to the page content, in 2025, AI-integrated motherboards are starting to appear in high-end consumer systems. They offer real-time optimization features that adjust power delivery, cooling profiles, and overclocking based on workload predictions.
Wait, so the motherboard is actually learning and adapting?
Exactly. The page content describes smart fan curves that respond not just to temperature, but usage patterns, dynamic voltage adjustments to reduce power consumption, and AI-powered BIOS assistants that guide users through overclocking or troubleshooting.
That's incredible. So manufacturers like Asus and MSI are actually putting AI chips on motherboards?
According to the page content, yes, manufacturers like Asus and MSI are leading this charge, integrating dedicated AI chips on their premium boards for real-time system tuning. It's wild that we went from needing separate cards for basic graphics and sound to having AI integrated directly.
And what about the physical size? Are motherboards getting bigger to accommodate all this?
Actually, the opposite. The page content shows that with advancement of chip manufacturing and integrated circuits, today's motherboards are more compact while offering more power than ever. Mini ITX and Micro ATX boards have made small form factor PCs viable without sacrificing performance.
So we're getting more powerful and smaller at the same time. That seems to be the trend across all tech.
Right, and there's this interesting sustainability angle too. According to Emanuele de Marinis from Contron, quoted in the page content, modern motherboards are designed with resource efficiency and energy conservation in mind, using environmentally friendly materials and optimized manufacturing processes.
That's smart. As these boards become more powerful, managing heat and energy becomes crucial.
Absolutely. And the page content mentions that AI is even helping with cooling system design. AI simulations can predict how air and liquid flow through a chassis before a prototype is even built.
So AI is designing the hardware that runs AI. That's kind of meta.
It really is. The page content describes machine learning-driven software going through millions of design options within hours, finding patterns and optimizations that humans couldn't duplicate. Companies like Intel and AMD are using these techniques.
Looking ahead, what do you think motherboards will look like by 2100?
Based on current trends in the page content, I think we'll see even more integration. The shift from multiple PCBs connected by wires to a single multi-layered board wasn't just about convenience, it fundamentally changed how fast data could move between components.
So maybe by 2100, the entire computer is essentially one integrated board?
Possibly. The page content mentions that motherboards are becoming more integrated and smaller, allowing them to handle complex tasks like AI processing and data analysis. We might see quantum computing integration, or boards that can reconfigure themselves based on workload.
That would be wild. Imagine a motherboard that could literally reshape its circuits based on what you're doing.
The page content does mention that AI workloads often involve large amounts of data processing and parallel computing, so future motherboards will need to be optimized for these tasks. We're already seeing this evolution.
It's amazing to think about this journey. From Patty McHugh solving a wiring problem in 1981 to AI-powered boards that optimize themselves in real time.
And the pace is accelerating. The page content shows how we went from basic integration in the 2000s, USB ports, SATA connections, basic graphics, to today's boards supporting DDR5 memory, PCI 5, and AI chips.
So, when you step back from all this, what's the bigger picture here? What does this evolution tell us about computing?
I think it shows that the motherboard has evolved from a simple connector to the brain of the computer. According to the page content, it's gone from supporting components to actively managing and optimizing the entire system. That's a fundamental shift.
And for anyone building or buying a computer today, understanding this history helps them make better choices about future-proofing their systems.
Exactly. The page content emphasizes that choosing the right motherboard is the best long-term decision you can make when building a PC. Features like DDR5 support, PCI 5, and newer sockets ensure your system can grow with technology.
Well, here's what I find most fascinating. We started this conversation talking about messy wiring problems in the 1970s, and we're ending with boards that can think and adapt. That's not just technological evolution, that's transformation.
And we're probably still in the early stages. When you consider that the page content shows most major innovations happened in just the last 25 years, imagine what the next 25 will bring.
The next time you open up your computer and see that circuit board connecting everything together, remember, you're looking at the result of decades of innovation. From IBM engineer Patty McHugh's simple wiring solution to today's AI-powered orchestrators. And this is just the beginning.